I wanted to give you a general overview of the ellipse. This is the general form of the ellipse, what I have written down right here, and I wanted to talk to you about it. What makes an ellipse special is that it has both an x squared and a y squared. Remember that the parabola only had one of those variables squared. And they're both the x squared and the y squared are the same sign, right? They're both positive or they're both negative. And so that's what makes an ellipse. Now, a circle is a special type of ellipse. That's when the A and B would be the same. If your A and B are exactly the same, then it is a circle. And so an ellipse is a more general type of circular type of thing. It's only a perfect circle if you're going out the exact same way. So let me just give you an interpretation. I need to make an assumption right now. I'm going to assume that A is greater than B. If A is greater than B, then everything is happening to the x. So it's elongated in the x direction. So the book is going to give you two different forms of this on the top of page 647. I believe that's a little bit of overkill. So if what you're paying attention to, whoever has the biggest value underneath it, that's where everything's happening. So if A is greater than B, everything's happening in the x direction. If B is greater than A, then everything's happening in the y direction. And we'll talk about what everything is. So for a focus here, I want to just have A greater than B. So what's happening is our ellipse will have a center at some value. Let's suppose that this is h and this is k. So at some value hk is what they call the center. So the center of the ellipse is at hk, which can be easily read. Now the ellipse also has what they call vertices, right? They're different than the vertex that we found with the parabola, but they still use the same name. So the vertices are found by applying the right number to the right variable. So remember, A is bigger than B, so x has the bigger number underneath it. So everything's going to happen to the x. So what's going to happen is the vertices are going to be affected by x, and we're going to add and subtract A, but keep that same k. So what does that do? That moves us maybe down here a distance A, and apologize, that's moving in the y direction. That's going to move us in the x direction, back A, and forward A. So the distance between here and here is A. That's the same distance in there, even though it may not look like it. So you're going an A distance out to get these vertices. Well, these vertices are where the ellipse is going through. Now remember, B is shorter. So the distance from here to here is A. The distance from here to here is A. The distance down is B. But B's not along what they call the major axis. So they don't really identify that other than in the graphing. So the vertices are always that A away. Now, inside are two focus points. So since there's two of them, they'll call them the plural of that, the foci. And everything again happens to the x variable. So we're going to add a number c is what they call it. Now what c is, for us, c squared is equal to a squared minus b squared. Remember, c's got to be inside the vertices, so c is smaller than a. And so we get c squared by taking the bigger one minus the smaller one. Right? So if a is greater than b, c squared is equal to a squared minus b squared. And so the c value would be inside, and these would be your two focus points that are right there. So let me do some highlighting. I'm going to put my focus points in red, right, or my foci in red, and I'm going to come through and highlight also in red, so those match up. My vertices I'm going to come in and put in yellow. Right, just come right on top, and those vertices are gotten by this guy right here, and the center was given to us in the very beginning. So that's what it's going to feel like. If for some reason, well, we'll see it sometimes, we'll see that B is bigger than A, then everything would happen in the y direction. And so your center would still be at HK. But since B is bigger than A, we're going to apply B to that. And so our vertices would be H comma K plus or minus B. Now remember, B is that bigger number. And then our focus points would be H comma K plus or minus C. Now, C in this case would be B squared minus A squared. C squared's got to be positive, so you're just subtracting those two. Our book treats them as different, but I just want you to envelop it all in the exact same type of formula. What would this one look like? It would have been elongated in the y direction, where your center is HK, and the vertices are a B distance away. And the A distance away would get you out to the curve, and your C distance would be right there, right, as you get those vertices. All this is very well explained on page 647, but I thought just having somebody talk you through it would be good. What we need to do is look at some examples, so we'll do that next.